All right, time for Unit 3, Lesson 1, Inverse of Linear Functions. So let's just go ahead and recall that functions have inverses that are also functions if they are one-to-one. So remember last lesson we did was inverse function. So this is just piggybacking off that. With the exception of the horizontal lines, all linear functions are one-to-one. Thus, their inverses are also functions. We're going to investigate this a little bit more in this lesson. Exercise number 1. On the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. A says, how can you quickly tell that y equals 2x minus 4 is a one-to-one function? Well, remember, in order to determine if a function is a one-to-one function, we always have to check by using the horizontal. Let me get back to my pen. The horizontal line test. The horizontal line. B says to graph the inverse of y equals 2x minus 4 on the same grid. Recall this is easily done by switching the x and y coordinates of the original line. I'm just going to go ahead and I'm going to change my color to blue. I'm just going to write down what all these points are of my original function so I can easily find the inverse. So I have, here I have negative 1, negative 6, I have 0, negative 4, I have 1, negative 2, I have 2, 0, 3, 2, 4, 4, and then this is 5, 6. So now remember, just to find the inverse, all I have to do is flip my x and y. So for my new ordered pairs for the inverse function is going to be negative 6, negative 1, negative 4, 0, negative 2, 1, 0, 2, 2, 3, 4, 4, and 6, 5. So C says, or excuse me, B continues to say to go ahead and graph it. So at this point, I'm going to change my color to purple just so we kind of have a better distinguish. Negative 6, negative 1, negative 4, 0, negative 2, 1, 0, 2, 2, 3, 4, 4, and 6, 5. And then you would draw a straight line through those points. So he says, what can be said about the graphs of y equals 2x minus 4 and its inverse with respect to the line y equals x? So this middle line right here is your y equals x line. And you can say that it's symmetrical across. It's symmetrical across the y equals x line. So remember, symmetry just means that it's the same distance from something. So if I were to actually pick up this piece of paper and I would fold it right here on this line, the y equals x line. My two lines, my y equals 2x minus 4, and this is the inverse of that, would be on top of each other. That's how you know it's symmetrical. B says to find the equation of the inverse in y equals mx plus b form. So we're already given that the equation is y equals 2x minus 4. And so now we're just going to find the inverse. Remember, when you're finding the inverse, you literally just flip my x's and my y's, and I solve for x. So x equals 2y minus 4. Add 4 to both sides. This is from the last unit. X plus 4 equals 2y. Divided everything by 2. So my answer would be 1/2 x plus 2 equals y. He says find the equation of the inverse in, that should be a y equals x plus b divided by a form. So again, all I'm doing is I'm switching my x's and my y's. So instead of y equals x plus b divided by a, I'm going to have x equals y plus b divided by a. I'm solving for y. So I don't know if you want to make a note that you're solving for y. So I'm going to first multiply both sides by a. So I have ax equals y minus b. So the inverse operation, oh, that should be plus b, excuse me. Inverse operation, so I'm going to subtract b. So I have ax minus b equals y. And that's my inverse equation of y equals x plus b divided by a. As we can see from part E in exercise 1, inverses of linear functions include the inverse operations of the original function, but in reverse order. This gives rise to a simple method of finding the equation of any inverse. This is what we've been telling you. All you're simply doing is switching the x and y variables in the original equation and solve for y. So in exercise 2, it says, which of the following represents the equation of the inverse of y equals 5x minus 20? So again, you just switch those. So I have x equals 5y minus 20. Add 20 to both sides because I'm solving for y. X plus 20 equals 5y. Divide by 5, and you gotta divide everything by 5. So I'm just gonna rewrite it because it says y is on the left. So I'd have 1 over 5x plus 4 equals y, which is also the same thing as 4. Y equals 1/5 x plus 4. Although this is a simple enough procedure, certain problems can lead to common errors when solving for y. Care should be taken with each algebraic step. So for example, on exercise 3 and 4, you have fractions. So exercise 3 says, which of the following represents the inverse of the linear function y equals 2/3 x plus 8? So again, I'm just switching them. So I have x equals 2/3 y plus 8. Now I'm going to just subtract 8 from both sides. So I have x minus 8 equals 2/3 y. Now I'm going to multiply it by the reciprocal. Remember, the reciprocal is just looking at your numerator now becomes your denominator denominator becomes your new numerator. Whatever you do to one side, you must do to the other. So when I do that, I'm going to have 3 over 2x minus 3 times negative 8 is negative 24, divided by 2 is negative 12, equals y. So the one that represents that is 2. For 4, it says, what is the y-intercept of the inverse of y equals 3/5 x minus 9? Again, all you're doing is changing them around. So I have x equals 3/5 y minus 9. I'm going to add 9 to both sides. So I have to do the inverse operation to undo. X plus 9 equals 3/5 y. Multiply by the reciprocal. So I'm flipping my fraction. What I do to one side, I must do to the other. I have to do it to everything. 5/3 times x is just 5/3 x. 5/3 times 9, well, 5 times 9 is 45. Divide by 3 is going to be 15. Equals y. And of course, when we have y equals mx plus b, because of course you can also write it as y equals 5/3x plus 15. So when I have this, my b is my y-intercept. So my constant is my y-intercept. So it would be y equals 15. Sometimes we are asked to work with linear functions in the point-slope form. The method of finding the inverse and plotting it, though, do not change just because the linear function is written in a different form. So remember, point-slope form is y minus y1 equals m times x minus x1. Which of the following would be an equation of this inverse of y plus 6 equals 4 times x minus 2? So the very first thing I would suggest to do is to go ahead and solve it in slope-intercept form. So I'm solving for y to begin with. So I'm going to have distribute my 4 throughout. So I'm going to have y plus 6 equals 4x minus 8. And I'm going to subtract 6 from both sides. Y equals 4x minus 14. Now I can do the inverse. So I'm going to have x equals 4y minus 14. Add 14 to both sides. I'm going to move it up here to have more room. X plus 14 equals 4y. So I'm going to divide both sides by 4 to get 1/4 x plus 7/2 equals y. Now when we're looking for this, we want to look for the slope. That's what we're looking for. Okay, so my slope of my inverse equation is 1/4. So which one of these options has 1/4 as the slope? The answer is 1. I want you to go ahead and pause the video and try to do 6 on your own. Actually, before you go too far, I want you to stop and I want you to look. It's a little bit of a different question. It says, which of the following points lies on the graph of the inverse of y minus 8 equals 5 times x plus 2? Explain your choice. So you just need to find the point. So remember, it's the opposite. So this is your y point. This is your y1. And this is your x1, right? And it's the opposite of whatever it is. So it's a positive 2. It's going to be a negative 2. A negative 8 becomes a positive 8. So that is what your point is for the function. If I want the inverse, I'm simply just switching them. So it becomes 8 negative 2, which is 1. The last example we have is exercise 7. Which of the following linear functions would not have an inverse that is also a function? So the key term here is would not. Okay? Would not have a function. So we need to look to determine which one would not be a one-to-one. Remember we said back in exercise 1, letter A, there is a clue there. It cannot be a horizontal line. So cannot be a horizontal line, okay? So we need to look here. Which one of these represents a horizontal line? Well, anything that's y equals is a horizontal line. So the answer is 3. Great. This helped. Drop any questions you might have.